This is the video for multiplication and division with decimals for the Health Science Bootcamp for Broward College. This is part 1, which will cover multiplication, and then part 2 will cover division. Before you complete these notes, you should read the section on decimals, which includes all the basics that you're going to need. When you're thinking about decimals, think about money, because that is the most common decimal that we see in our daily lives. Now, before we actually do any multiplication or division in part 2, you have to know how to round, because some decimals are irrational and they go on forever and ever and ever. So rounding a decimal basically cuts off a portion of it and keeps a portion. Now, the portion that you keep, you have to look at the ending digit. Okay, that ending digit is either going to stay as it is or bump up to the next value. So the directions will tell you which place value that you're rounding to. So you're going to mark it. You can mark it with an arrow, is what the chapter says. Then we're going to look to the right. So the next number in the list, and we're going to see if that number is 5 or bigger. If that number to the right is 5 or bigger, then you're going to bump your ending value up. If it is not 5 or bigger, so 0 to 4, you're going to keep your ending digit. So you'll never make it less, but you might bump it up. Let's try it. Round to 2 decimal places. So I have the number 3.219. So since we're doing 2 decimal places, this is where I'm going to stop. So my answer is either going to be 3.21 or 3.22. What I need to do is look one place to the right, because this place has 5 or more. I'm going to bump up my 1. So my final answer would be 3.22. Let's try it again. 15.982. So I'm doing 2 decimal places. So the 8 is where I'm going to stop. So my answer is either going to be 15.98 or 15.99. I'm going to look one digit to the right. 2. That digit is less than 4. So that tells me I'm going to keep the 8. So my final answer would be 15.98. Let's try another one. 980.595. So we're rounding to 2 decimal places. That's the 9. So either my answer will be 980.59 or 980. Wait, my 9, if I bump it up 1, it would go to 10, which kind of wraps around. So think of this as 59. If I bump that up, it would bump up to 60. So my answer would either be 980.59 or 980.60. So just like an odometer, when you bump up from 9, it will also bump up the number to the left. But we need to decide which way to go here. Maybe a moot point. So I look to the right. The number to the right is a 5. 5 or bigger, you bump. So we're going to bump it. So this will become 980.60. Okay, let's try one more. 1,472.601. So I'm going to either have 1,472.60 or 1,472.61. I look to the right. The number to the right is 1, which is between 0 and 4. So I'm going to keep that digit. So my final answer will be 1,472.60. So depending on which health science field you go into, you'll be rounding to different places. And you always want to check the rules of your particular job to make sure that you're rounding appropriately. Because if you're rounding something like medicine, if you round it too much, you might give the patient too much medicine, or if you round it, if you don't round it enough, then you might give them too little medicine, right? So now let's get to how to multiply with decimals. So this comes from the section that we give you to read about multiplication and division with decimals. And by that point, the decimals are either positive or negative. So you'll see here it says step 1, determine the sign of the product. Since we're in the health science field, all the values will be positive. Okay, so the sign of the product will always be positive. We're going to write our numbers in a vertical format just like we did for regular multiplication, but we're still going to line them up to the right. So we're not trying to put decimal over decimal. We're just right justifying our multiplication problem. And then we multiply just like normal. But then at the end, we're going to have to put the decimal point in. And this is where the magic happens. The number of decimal places in the product, so the product is your answer, is going to be the sum of all the number of decimal places from the factors. So you're going to look at each factor, each number that you multiplied, and you're going to count the number of digits after the decimal point. So those are the number of decimal places. And the total number of decimal places between all the numbers you're multiplying is how many decimal places your final answer should have. And again, this step 4 says write it with the appropriate sign, but here the sign is always positive. Let's try it. So 13.6 times 5. So I'm going to line them up just like I would like normal. And I'm going to do my multiplication. Now, you should have already read that section, practiced, watched the video, and practiced in your assignment, and maybe even taken a quiz on that material. And so you should be familiar with how to multiply. So the good news is in multiplication of decimals, you multiply like normal. So 5 times 6 makes 30. So 0 comes down and the 3 goes up to carry. 5 times 3 makes 15 plus 3, so 15, 16, 17, 18. So the 8 comes downstairs and the 1 goes upstairs. 5 times 1 is 5, plus 1 is 6. So I've done all the multiplication. I did 5 times 6, 5 times 3, and 5 times 1, and I added any carryover from the previous calculations. Now we have to decide how many place values our problem needs. So my first factor has 1 digit after the decimal. My second factor is just a 5. There was no decimal places. So my answer should have 1 decimal place. So I'm going to take my 680 and I'm going to count 1 decimal place, and that's where my decimal goes. So you're counting from the right the number of places before you put your decimal. Let's try it again. So I have 25.3 times 2.2. So this one has more than 1 digit in the second factor, which means we're going to have partial products that we add together. We do not put any decimals until we finish the sum of the partial products. So let's do this. 2 times 3 makes 6, no carryover. 2 times 5 makes 10, so the 0 is downstairs, the 1 is upstairs. 2 times 2 makes 4, plus 1 makes 5. Now we'll do the second partial product, and just like normal, since I've moved 1 digit over, I have to put a 0 at the end, and now I'll do this math again. 2 times 3 makes 6, no carryover. 2 times 5 makes 10, so 0 goes downstairs and 1 goes upstairs. 2 times 2 makes 4, plus 1 makes 5. Those are our 2 partial products. Let's add down. I get 6 and another 6 and a 5 and a 5. So now I need to decide how many decimal places should I have. So the first factor, 25.3, has 1 digit after the decimal. And then my second factor, 2.2, has 1 digit after the decimal. So that's a total of 2 digits. So I need 2 digits after my decimal. So what is 25.3 times 2.2? That's 55.66. Okay, let's try 57.2 times 10. 57.2 times 10. So first I'm going to multiply by 0. 0 times 2 makes 0. 0 times 7 makes 0. 0 times 5 makes 0. Now I'm going to move 1 place over to the 1, so I'm going to put a 0 at the end, and I'm going to do the math again. 1 times 2 makes 2. 1 times 7 makes 7. And 1 times 5 makes 5. Do the math, and I have 5, 7, 2, 0. Then we're going to count our decimal places. So my first factor has 1 decimal place, and my second factor has 0 decimal places. So that totals 1 decimal place. So I count 1 digit from the right, and that's where I put my decimal. So my answer would be 572.0. Now, generally, we don't write the 0 because it's all zeros at the end. But since we're doing decimals and I had the 0 in my answer, I'm going to keep it. It's still technically right. Let's try again. 37.5 times 1.3. So 3 times 5 makes 15. 5 is downstairs, 1 is up. 3 times 7 makes 21, plus that 1 upstairs makes 22. 2 is down, 2 is up. 3 times 3 makes 9, plus those 2 would make 10, 11, so 11. Now we're going to drop a 0 because we're moving over a decimal place. We're moving over a place value. And we'll do the multiplication. 1 times 5 makes 5. 1 times 7 makes 7. 1 times 3 makes 3. So now we're going to add these two guys together because they're partial products. So 5 plus 0 is 5. 2 plus 5 is 7. 1 plus 7 is 8. And 1 plus 3 is 4. Now we have to decide where to put our decimal. So my first factor has 1 digit after the decimal. My second factor has 1 digit after the decimal. So my answer, my product, will have to have 2 spaces after the decimal. 1, 2. So this is where my decimal goes, 48.75. One more, 6.89 times 13.7. So 6.89 times 13.7. This one's going to have 3 partial products because the factor that's on the bottom has 3 digits. So we're going to do this math. 7 times 9 makes 63. So the 3 goes downstairs and the 6 goes upstairs. 7 times 8 is 56. Plus 6 makes 62. 7 times 6 is 42. Plus 6 is 48. Now I'm going to multiply by 3. So I'm going to erase my carries here because I would need the room. Since I'm moving over a digit, I'm going to drop a 0 and then I'm going to do my math again. 3 times 9 is 27, carry the 2. 3 times 8 is 24, plus 2 is 26, carry the 2. 3 times 6 is 18, plus 2 is 20, so I'll write 20. Now I'm going to move over a decimal space, so I have to put another 0, so 2 zeros, and now I'm going to multiply by 1. So 1 times 9 is 9, 1 times 8 is 8, and 1 times 6 is 6. Then we add all these partial sums together. So I've got a 3, a 9, a 23, 14, 9. So now, how many digits do I need after my decimal place? Well, my first one has 2 digits after the decimal place, and my second factor has 1 digit after the decimal place. So I'll need a total of 3 digits after the decimal. So 1, 2, 3, and then I put my decimal point in. So 94.393. Now, when you're putting in the decimal, you have to be really careful because if you mess up the decimal when you're doing multiplication in the field, you could, again, give too much medication or not enough medication. So I'm just going to mention that there is an estimation process. For example, in example A, here, 13.6 times 5. 13.6 is close to 14. So if you can do 14 times 5, which makes 70, that means your answer should be close to 70. So when you have the 680, the most logical place to put the decimal is in between the 8 and the 0. Now it works even if both both numbers have a decimal, right? So 25.3 is really close to 25. And 2.2 is really close to 2. And if I do that multiplication, I get 50. So my answer should be close to 50. So it would make the most sense to put the decimal between the 5 and the 6. Because if you put it between, say, the 6 and the 6, then you would have 556, which seems awfully far from 50. And same if you put it in between the 5 and the 5, you would have 5.556, which is again pretty far from 50. So the most logical place would be in between the 5 and the 6. Now, you might have noticed in part C here that we multiplied by a 10, and we had to do, or when we were doing our long division, we had this row of 0 as a partial sum. And all that did was basically move the decimal of the factor. So the factor was 57.2, and I timed it by 10, and I got 572. So the decimal just moved over to the right. This is not a coincidence. Remember when we were doing multiplication of whole numbers, if you multiplied by 10, you tacked on a 0. Well, that was basically moving your decimal over and filling that empty space with a 0. Now we'll move our decimal over the same amount of zeros that we have in the factor. So you're multiplying by 10, that has 1 0, so the decimal moves one place to the right. If I was multiplying by 100, the decimal would have to move 2 places to the right. So the number of spaces that you move is based on the number of zeros in your multiplication. And you're going to have a lot of multiplication by tens and hundreds and thousands, and dividing by tens and hundreds and thousands, because the metric system is all base 10. So it's really helpful to be able to do the multiplication by 10, 100,000 without actually have to write anything down. Okay? So there's a rule for that. So recall when you're multiplying a whole number by a power of 10, we just tack on the appropriate amount of zeros. When your factor has a decimal, we'll, instead of tacking zeros on, we're going to move the decimal to the right based on the number of zeros in the other factor. But if you do run out of decimals, then you'll start tacking on the zeros. Let's try it. So I've got 162.1 times 100. So since 100 has 2 zeros, I need to move my decimal place 2 to the right. Now you see how I'm missing a space here. It's blank, so I'm going to put a 0. So my answer would be 16210, which is 16,210. Let's try 953.136 times 10. So 10 has 1 0, which means this decimal just moves 1 to the right. So that would give me 9531.36. So 9,531.36. Let's try one more. 9375 times 10. Now, technically, the decimal is here, right? In whole numbers, we don't generally write the decimal, but the decimal's at the end. So my 10 has 1 0. I need to move my decimal one place to the right, and since there was nothing there, I'll tack on a 0. So I have 9375 which is 93,750.